It is with great pleasure that I welcome you to this important session on AI and sustainable agriculture towards global food security. As we gather here today, we are acutely aware of this critical juncture at which our global agricultural systems stand. With the mounting challenges of climate change, population growth, and resource scarcity, the need for innovative solutions has never been more pressing. In this context, artificial intelligence emerges not just as a tool, but as a transformative force in the pursuit of sustainable agriculture and food security. The Global South, where agriculture forms the economic backbone, accounting for almost 30% of GDP and over 60% of employment, stands at the forefront of this revolution. However, it is also here that the impacts of climate change, manifesting in extreme weather events, are most acutely felt. Thus, the integration of AI in agriculture is not merely a matter of technological advancement, but a vital step towards resilience and sustainability. Our session today is dedicated to unfolding the potential of AI in revolutionizing sustainable agriculture. We will delve into the opportunities that leverage AI innovations in sustainable agriculture presents, particularly for the Global South. This will include examining case studies and successful models of AI deployment in agriculture, and discussing how these can be replicated and scaled. The responsible and successful deployment of AI in sustainable agriculture requires careful consideration. Our discussions will also focus on the potential frameworks for public-private partnerships and policy development, which are crucial for catalyzing AI innovations in this field. Agricultural innovation requires a cooperative and network-based approach underpinned by such partnerships and policies that not only foster innovation, but also safeguard the rights and interests of diverse communities. Through this discussion, we hope to set in motion a collective journey towards a future where sustainable agriculture, powered by AI, plays a pivotal role in achieving global food security. With these thoughts in mind, I would like to call upon our esteemed keynote speaker, Dr. Yossi Matthias, Vice President of Engineering and Research at Google, onto the dais. So please. I would also request our distinguished panelists to join us on the dais for a commemorative photograph. I invite Mr. Rajneesh Kumar, Chief Operating Officer and Director, Capacity Building and Finance of National E-Governance Division, Digital India Corporation, Ministry of Electronics and IT. Dr. Vikram Adve, Professor Donald B. Gillies, Professor Donald B. Gillies, Professor of Computer Science, University of Illinois. Dr. Manish Gupta, Google Research, India. Mr. Shekhar Sivasubramanian, CEO, Vadvani AI. Ms. Meghavi Prashnani, South Asia Lead, NASA Harvest. Ms. Shobhini Mukherjee, Executive Director, GPAI. It is now my distinct honor to introduce and invite our keynote speaker, Dr. Yossi Matthias. As the Vice President of Engineering and Research at Google, Dr. Matthias is a luminary in the field of technology and innovation. He leads global teams that are at the cutting edge of research and development, focusing on impact-driven initiatives that harness the power of AI to address some of the most pressing challenges of our time. Dr. Matthias's work in advancing AI technology spans several critical areas, including healthcare, generative AI, and notably the climate crisis, an area of immense relevance to our theme today. It is with great enthusiasm and a sense of anticipation that I invite Dr. Yossi Matthias to the stage.
Well, thank you very much for the kind introduction. Great honor to be here today. And my name is Yossi Matthias. I'm leading teams working on what I like to call impact-driven research, innovation, and moonshots. And one of the areas that I'm particularly excited about is the opportunity with AI addressing the climate crisis and sustainability at large. So great honor and pleasure to be here. Now, from experiencing the hottest summer on record to dealing with frequent and devastating floods and wildfires, we already see the impact of global warming. And this is touching our global communities in any aspect. Bigger storm, more frequent and intensified wildfires, more floods. And I guess India, of course, is one area that we see a lot of that. And we know that this impacts especially vulnerable communities. Now, we do believe in the power of AI to help and in these matters. And this is what many of us at Google Research are working on, to look into what we can do with AI to help with that. And of course, there are many others around the world. So I'd like to touch on a few of these areas and the opportunities that we see with that, of doing that. So I'd like to share a few examples of where we're leveraging AI, climate, and sustainability through some of the climate resilience, adaptations, and mitigations, and both in terms of how to try and slow down the global warming, how to address the adaptation, and then touch on how we're dealing with agriculture-related stuff, which is a topic for today. Now, according to our new report with the Boston Consulting Group that we just recently released, AI has the potential to mitigate 5 to 10% of global greenhouse gas emissions. Now, this is based essentially on extrapolation of what we do today. But importantly, we should remember that with AI, as it is with technologies in general, we can be surprised quite often for the better, I would say, in terms of the impact of what can be done. So hopefully I can convince you on that. But before I do that, I'd like to mention that we have been looking into AI now for several years. You know, we've been an AI-first company now for several years, and but we take AI very seriously. So one of the things that we set up early on is what we call the AI principles, and realizing that AI is an important technology, but it's extremely powerful, and we want to really be respectful to implications of AI. So we set up these principles by which we are looking into how to use AI responsibly and take into consideration areas such as security, privacy, bias, fairness, equitability, and of course, meeting to very high standards and all of that, not only in terms of our operation, but also in terms of how to develop some of the know-how and to develop some tools. So we'd like to think about how we're thinking about AI in terms of being both bold and responsible. Now, let me start with the opportunities of AI, and one of my examples, which is very much also relevant here, is flood forecasting. And this is something we actually piloted for the first time in India back in 2018. And importantly, when we started looking into flood forecasting, which is perhaps the most frequent and one of the most devastating natural disasters, impacting thousands of lives, actually causing the loss of thousands of lives per year, impacting many millions of people and billions in economic damages. And at the time when we started looking into that, the situation was that the general consensus among the experts was that this is too difficult problem to do something useful with in terms of prediction, which is really the main way to actually be helpful with floods, is actually to be able to give some predictions. So with that in mind, we started looking into what can we do about it. And what we learned is that actually we can make some progress on that. So now, a few years ago, I was here actually in India, and I saw actually the impact of floods, seeing a village that was covered overnight. At middle of the night, actually, flood came unexpected. And the fellow standing next to me, Rakesh, is a real hero. He actually, and two of his friends actually saved quite a few lives that night on that village. Not everybody, unfortunately. But the main question that was on our mind is, can we actually give predictions so that we don't need to rely on such heroes such as Rakesh? And the way in which the solution actually turns out to do a pretty good job at that is by a technology called flood forecasting that is a result of actually advancing science and technology, working very closely with academics, publishing papers, and a combination of machine learning and physics simulation in which we build what we call essentially two types of models. One is the so-called hydrologic model, which tells you how much water you should expect to get down in any particular location. And this is a pretty complex problem because you need to take into account the wear of the land, take some measurements, make some predictions, account for different soils, and many other kind of considerations. And the other one is the so-called inundation model, assuming you know how much water arrives in a particular case. In order to be helpful, you need to actually give prediction of what's going to be the water level there. So these kind of combined can give you a pretty good sense, which today we can actually give it as what we call this and dissemination through our tools. And in India alone, we sent out many millions of notifications to people at risk. Now, the problem appeared to be at first too difficult to solve because there are so many variables. But as it turns out, with enough computation power and simulations and physics and data that was gathered and in partnerships, we could actually do something about it. And fast forward, later we could actually build up what we call the breakthrough global hydrologic model that actually learns, using machine learning, all those patterns of hydrology, and in a way that you can actually make predictions even in places that don't have as much historical data as other places. So for example, currently this is launched in what we call Flood Hub in over 80 countries, including 23 countries in Africa where the data is scarce. In India, actually, there's a very good system collecting data, measuring it, measuring the water level, the water velocity, reporting all of that, etc., which was extremely helpful and gives a very highly accurate result. Turns out that with this global hydrologic model, we can actually make predictions even in places that we don't have as much data. So essentially, this is an example, and what we see here is what we call a flood hub, where every dot is a gauge where you can actually see some predictions. The red dots are places actually there's a prediction there's going to be a danger level, and people can then prepare and take action, and this could be life savings. So that's an example for a problem that that really is impacting people's life using AI, and something that was thought to be unsolvable. This year alone, during the monsoon season in India, we sent 46 million notifications to people at risk. So it's pretty impactful. Let me give another example. Floods represents this class of problems which we call adaptation. Namely, they existed for years, of course, but now with climate change and global warming, we have many more of them and more intensified. And by the way, globally, right, we've seen in Europe, in other places, floods that we haven't seen in ever. And also here, I believe in Delhi and other places, we've seen floods in increased capacity. The other direction we're looking into is how can we use AI in order to help mitigate the climate change. So let me give an example of a project called Greenlight, which is based on the following observation. It turns out that much of the carbon emission, of course, is due to transportation. Much of it is in the cities. Much of it is in intersections. So intersections is not only a place that is irritating to be stuck at during a traffic jam, but also it turns out that one of the events that contribute a lot of carbon to is really this so-called stop and go kind of events. And the team looked into the question, can we actually do something about it? Can we find a better way to optimize the scheduling of traffic lights just by looking into the traffic data that we have in the aggregate? And it turns out that we can. So the carbon emission in those intersections is 29 larger than in the open road. Turns out that we can actually analyze the data, no sensors are required, just using traffic data that is in the aggregate, and then using some AI heavy lifting in order to get some optimization. But all the city needs to do is just to go and change a little bit the scheduling of a traffic light. Turns out we can reduce the events of stop and go by 30%, which translates into 10% of carbon emission. Now, to me, this example illustrates the power of identifying areas that you don't need to do some fancy installation or expensive ones. Actually, you just observe a place that you can use technology in order to do something which is better and saves a lot of the carbon emission that we have. And one question that is begging to me is what else can we do with such ideas? So these are kind of a couple examples, and this is something that we've run already in over a dozen cities globally, including one in Calcutta, and we're expanding to other places around the world. With that, let me switch to sustainable agriculture, which is actually the kind of the main topic for today here. And we believe that AI can improve agricultural sustainability, beginning with the global south. So as all of you here know, for India, agriculture is critical. About half of this country's population depends on agriculture. And as a lead producer of basic products such as rice, wheat, cotton, sugar, and dairy, India's agriculture is essential for the entire world. Situation is similar in other countries in the global south, as many African countries, which have the greatest burden of food insecurity. 70% of Africans rely on agriculture and farming for part of their income. Now, within that context, farmers are some of the most important stakeholders. Yet there are daunting challenges every day, ranging from getting access to subsidies, capital, insurance, achieving better yields, market linkage due to a variety of reasons. So changing climate, monsoon, and variability, and declining soil fertility are compounding existing challenges. And even though there's rapid adoption of smartphones and great penetration of internet in India, the usage of technologies in agriculture is fairly limited. So the opportunity is really big here. Now, without change, food and environmental systems across the world are at risk. That's why we're advancing research and working with partners, governments, NGOs, and startups to apply our AI research and help address these challenges. Now, Google teams in India are applying AI to organize the agricultural information in the individual farm yield level to enable field-level targeted interventions, data-driven decision-making, and delivery of services at a farmer level, not only in India, but in other regions as well. We're doing this in a few ways. So let me highlight a few of those. First, we are using AI-powered technologies to organize India's agricultural data and develop a unified landscape understanding. We're building for agriculture via assets such as Earth Engine and AI models such as agricultural landscape understanding. This technology is helping us understand the fundamental elements of agricultural landscape through a multi-class model that segments field and tree crops, trees, woodland, water bodies like dug wells and farm ponds. Furthermore, we're launching a new space where developers, agri-tech enterprises, and governments can learn more about their work and start using the output of our models through APIs. And this will be available on a new website, which is going to be up there called agri.withgoogle.com, so pretty straightforward. Now we're starting our agricultural landscape understanding API in India with more capabilities to be added in the coming months, including more regions in the global south, beginning with Africa. Now second, we're applying AI for agricultural monitoring and event detection. This enables the exploration of details of an individual field and the review of agricultural practicals throughout different periods to better understand its needs. Details include current crop types, field size, distance to water, and other important venues. Allows us to explore specific activities like sowing, harvest, or tillage for a specific field. In these technologies, future landscape monitoring models would be able to determine data like crop type, field size, distance to water, and crops last sow or harvest date. And you can see some of them in some of the booths here in the expo. All of our research is made possible through meaningful partnerships with governments, academic institutions, local communities. Today, our model outputs are being used across a spectrum of partners, including central and state government institutions, agri-tech enterprises, and academic institutions. Third, we're supporting farmers with Google Cloud through pioneering work to provide advanced AI language capabilities that can solve for last-mile barriers to adoption by farmers. Our partners such as Protein, eGov Technologies, and Amnex are building innovative solutions, leveraging our technology to provide precision advisory, access to formal credit via field digitization, get inputs on best practices, etc. They're also working with FPOs and ONDC to help solve for market linkage for farmers, generative AI can play a big role in such scenarios. Now, taking this further, today I'm happy to announce our partnership with Protean. Protean will soon be launching an Android app called ProKisan, a one-stop shop for farmers in India. This app is powered by Google Cloud's generative AI to automatically create catalogs for farmers' produce. The app will also generate and enable bite-sized learning for farmers via the Honest network and provide advisory throughout the crop life cycle in the regional language with voice capabilities. Now, another way we're advancing sustainable agriculture is by supporting startups, which is a topic really close to my heart. And by the way, it was great to see all the startups pavilion here in the expo. Our goal for Startup for Sustainable Development program is a global program, global ecosystem of more than 500 impact-focused startups spanning 70 countries. 500. One example is WHR Loans. This startup helps farmers, traders, and producer companies in raising working capital through blockchain loans against their commodity stock, deposited in warehouses and pledged with the lenders to tide over lengthy crop cycles ranging from 6 to 12 months. Another example is a startup, Ndrip, which is operating here in India. Actually, I was sitting with them in a panel just last week in COP28 that has developed a micro-irrigation solution powered by gravity, a sustainable alternative to flood irrigation. This disruptive technology provides precise irrigation, producing higher yields while saving water without adding energy and without the need for water filtration. As farmers, governments, and international organizations are actively seeking alternative, more efficient and less wasteful solutions to flood irrigation, this technology can help change water use in agriculture to help solve the global water shortage. Our climate and food systems are deeply interconnected as the impacts of climate change become more severe. The world's food security will depend on the resilience and innovation of our agricultural systems. So apart from helping farmers and supporting sustainable architecture, we're applying AI to forecast food insecurity and provide vulnerable insights to our partners. Over the last decade, food insecurity has been increasing worldwide. Although India, in India, for example, has enjoyed steady economic growth and has achieved self-sufficiency in grain production in recent years, high levels of food insecurity persists. India is home to a quarter of all undernourished people worldwide. Now, we believe there is a need for new data and methods for forecasting food security for three main reasons. Better forecasting methods can inform anticipatory actions, which have been shown to be up to 34 times more cost-effective than reactive measures to crisis. So the notion of prediction and forecasting, which I know that the PM also referred to, is extremely important. We've seen the importance of that in other areas as well. Food insecurity is a complex phenomenon influenced by the multitude of factors, including climate change, armed conflict, politics, and economic shocks. There's a general lack of data on food security outcomes and indicators, necessitating the use of novel data sets and surrogates for modeling food security. Now, research teams in Nairobi, Kenya, is working on early stage research applying AI to address this challenge. We're using existing food insecurity data sets, such as data on weather and economic factors, and plan to make use of Google's unique data sources and tools such as Trends, News, Maps, and Earth Engine. The goal is to extract multimodal data about food insecurity outcomes and drivers. We'll use this to create time series models that are capable of handling complex data, and we'll fine-tune Google's large language models to interpret and summarize the information generated by our forecasting models. We hope to provide users with insights such as forecasts, recommendations, and status reports by doing this. Forecasts which are continuously updated, varied data sources, potentially more granular, easily scalable. We hope this will help guide anticipatory action to avert emergency situations. Now, there are so many ways and so many more challenges that AI can help solve, and that our teams are working on, and not only our teams, teams of other places, other companies, many startups, and governments, institutions, and more. And this is just the beginning. Our teams at Google are committed to doing whatever we can to leverage the power of AI responsibly by designing AI systems that are beneficial, fair, safe, and accountable to everyone. We aim to help people and partners with accurate predictions and information that can be helpful for everyone. So with that, and I'd like to highlight just a few of the items that I think are the main takeaways as far as I'm concerned from our experience so far and prediction looking forward. One, when we talk about these societal problems, it's one of those opportunities for all of us to work together, to work across industries, to work with NGOs, with governments, with startups, with academics. The other observation is that when we look, coming from, again, COP28, all the predictions are pretty grim in terms of the progress. The optimist in me says that, well, technology is not linear. Progress is not linear, so we can actually use technology in order to make a change and to shift gear in so many different aspects. If there's something to learn from our experience in flood forecasting, is that even problems that appear to be too difficult may actually be solvable. And in most of them, I would expect to be solvable. With progress in technology and AI, I expect that almost every problem that we're going to encounter, we're going to find a way to solve. If there's something to learn from the likes of Greenlight, is that there are out there various opportunities to identify low-hanging fruits which are there, we just didn't find them as yet, which touches also another aspect, the innovation, the ideas, the identification of problems and the way to solve them can come from many. And that's why we're so keen on working with startups and mentoring startups and look into how to support others who can come up with solutions and leverage technology. And today, more than ever, I think we're in a very exciting time where the ability to actually harness technology to solve difficult problems is unprecedented. And also the opportunity for, when I meet young people, I tell them that I don't think there was ever a time in history that people could actually learn a skill and then harness technology which is already available to them and solve problems that actually make impact on people's lives so quickly and so effectively. So with that, I'm looking forward to hearing more about what's going on here and looking forward to see how we can harness AI to help out with climate crisis, sustainability, and agriculture. Thank you very much.
Thank you, Dr. Matthias, for your very informative presentation and your remarks. As we continue to delve deeper into the realms of AI and sustainable agriculture, it is my privilege to introduce the moderator for our panel discussion, Mr. Rajneesh Kumar. Currently serving as the Chief Operating Officer and Director, Capacity Building and Finance of the National E-Governance Division at the Digital India Corporation under the Ministry of Electronics and Information Technology, Government of India. Mr. Kumar is a figure of immense knowledge and experience in the intersection of technology, governance, and societal development. Mr. Kumar, we are eager to hear the panel's insights and discussions under your skilled moderation. Sir, the stage is all yours. I would also like to request all the panelists to kindly come up on stage. Dr. Vikram Adve, Professor of Computer Science, University of Illinois, Dr. Manish Gupta, Google Research India, Mr. Shekhar Sivasubramanian, CEO Vadvani AI, Ms. Meghavi Prashnani, South Asia Lead, NASA Harvest, Ms. Shobhini Mukherjee, Executive Director, GPAI.
Thank you, Antru. Well, after a very informative presentation by Dr. Yassi, We welcome all of you to the session on AI and sustainable agriculture towards global food security. So as I can sum up what Sir said, that AI can mitigate about 5 to 10% of the global greenhouse emissions. Of course, there are some issues that does the AI technology also increase pollution? That, of course, is a separate discussion. Then we have to be bold and responsible. The very good potential of AI is flood forecasting, because which are one of the bigger problems of countries like India. The prediction of weather has two models, hydrologic and inundation model. Sustainable agriculture, and he also introduced us to a website called agri.withgoogle.com. And one of the important things that we could take away is that Google is supporting startups, which is a whole ecosystem approach, holistic approach. And like he gave examples of WHHRL loans and DRIP. So as he mentioned the challenges and highlights of the session and his PPT, that we need to have a holistic view on things, whole system approach, and problems which seem very difficult are actually very solvable. And the most important thing is that they have to mentor startups and have the entire ecosystem and innovation by the young into agriculture. So as we proceed, I would like to first ask questions to the panelists. Dr. Martinez has not come yet. So I will start with Mrs. Shobhini Mukherjee, ma'am. See, throughout your illustrious career, you have worked very closely with policymakers, civil society partners, and research institutions. So in your understanding, what are the key obstacles that farmers, particularly India and South Asian regions, encounter while trying to adopt and integrate AI into their agricultural practices? And the other question is, can AI be made accessible and beneficial to the smallholder and non-digital farmer demographic? Ma'am, please.
Thank you very much. I'll just spend a minute talking about the kind of work that I do, what the Poverty Action Lab does, so it'll just give you a little bit of a better idea when I give a few examples of just to answer what you said. So the Poverty Action Lab is a research network of more than 500 professors across the world who are using randomized evaluations to be able to answer solve various challenges across various sectors, understanding what works, what doesn't in alleviating poverty. Now, we work across many different fields. We work across agriculture, of course, but health, education, climate change, energy access. We look at behavior adoption. We look at gender, crime, and labor markets, what have you. And the basic premise is that there are many solutions that exist to be able to alleviate poverty, but the underlying principles of establishing causality to that program is what we're all about. So whether something works or not, we want to be very sure, given the fact that there are many solutions that exist, but how do you adopt better practices, whether better healthcare, preventative healthcare practices, better education pedagogy, how do you look at digital extensions for agriculture for farmers? A lot of the underlying principles are behavior driven as well. So we make the mistake of thinking that technology is the silver bullet, but then how do you get communities to adapt, to adopt these practices into their everyday lives? And that's really part of the focus that we have is on evaluating in the most rigorous way whether something works or doesn't. And then we work a lot with governments across India. So we work we are a regional network across seven regions across the world. And in India, we're working about 20 state governments across all of these domains to understand how do we scale effective programs and policies based on evidence. We were headquartered at MIT, and that's where our within the economics department. But that's where the origins are. But in India, we're with IFMR. It's a business school in southern India. So that's just a little bit about what the Poverty Action Lab does. To answer your question more specifically, now in agriculture, a lot of our work has been around adoption of best practices. The technology is good. We've got solutions. We're talking about AI right now, but in general, just better practices to improve crop yield, higher incomes, looking at how do farmers switch cropping patterns, how do you use agricultural extensions and IVR, phone-based messaging to be able to inform farmers about what are the market linkages, where to sell, what, how, all of that. A lot of this, we've evaluated across many organizations. We've used many tools. So we've used tools from Wadhwani and Google as well. But one of the main barriers that we find here is just the adoption. And underlying behavior principles are very important to understand. What is the adoption? It's good for you, but how do you nudge people to really adopt at a large scale? And the two things that come in play here. One is just the fact that there is low digital literacy. So you might have mobile penetration, but this digital literacy is one challenge. So how do you solve for that? And AI possibly cannot solve for it. So a lot of it has to do with training and using social networks and using sort of communities on the ground to be able to do that, to leverage that. So we've done some work around how do you use social networks to spread information? How do you use frontline workers to be able to just push that forward as well? And we've done some interesting work around, say, looking at early warning flood systems, and that's again with Google technology, but then also having frontline workers who are actually taking that to the communities. So it's a little bit of just bridging that digital divide, bridging that knowledge. The other is just lack of trust in new technologies, and we are seeing that in some of the populations of farmers that we are working with. It's not a resistance, but it's lack of knowing of the unknown. And how do you stem that? Is again through social network. They see somebody else using it, and then they are better prepared to be able to adopt that technology. So there again, some of our work is around nudges and incentives for better behavior adoption. Some of it could be financial, some are non-financial, some are using peer and social networks.
Ma'am, do you have any examples that you gave that you could nudge a farmer to use AI or something? Any examples that you have?
So I can talk about something that we did in Punjab, in Punjab, over the last couple of years. So we've been trying to look at how do you reduce air pollution through reduction in crop burning. So everybody knows that it's a challenge in India. And one of the ideas was, again, we're all developing economists, and what we try and do is just sort of look at a development issue, but solve from a different perspective. So this was almost looking at how do you solve for air pollution, but through behavioral nudges and incentives to farmers to reduce crop burning. So the incentive was essentially giving farmers, I think some 8,000 rupees or something to be able to offset the cost that they have, which is, again, all of us know that there's the whole cropping season that the stubble has to be burnt very quickly to be able to prepare for the next cropping cycle. So, and then of course these feeder machines that the government has, those happy seeders and happy feeders and all of that, also very expensive. So how do you offset that opportunity cost and the cost of time for that farmer to be able to wait, recrop, take the fodder somewhere else and use that happy seeder? So the money was essentially to offset that incentive, but the idea was to see how many farmers take this incentive and they don't burn. So this was one of the nudges, and it was a very interesting experiment because we looked at, again, how much trust do farmers have in the system? So the money, some amount of money, some farmers, the randomized evaluations, we had a comparison group and several treatment arms. So one treatment arm actually had farmers getting the money before they had to actually burn the crop, before they had to sow for the next season. One was after, and then one was staggered. And we found that there was zero trust in the system, and then farmers who were told that we give you the money after, they all just burnt. But then there was, again, when we staggered it or gave the money up front, those had better returns. The interesting thing of using AI here was that we looked at technology. We partnered with Google here to look at satellite imagery. And then we were able to detect across very large tracts of land, which farmers were burning. And that gave us real-time information to be able to corroborate with the different treatment arms that we had. So it's a very quick way of being able to corroborate two kinds of data, but also in real time know whether these incentives are working on the ground or not.
Thank you, ma'am. You have given us a good exposition. I would now like to come to Dr. Vikram Adve, sir. You have co-authored a very insightful report as a GPAI expert on broad adoption of AI by SMEs in the agriculture and farming sector project. This work is, of course, very relevant to countries like India. Can you share some insights on how we can bridge the digital divide to ensure equal access to agriculture technology, especially for small-scale farmers and those in remote areas? Thank you, sir.
Yeah, so I think adoption of digital technology at many different levels, there are different challenges, especially in small farm sizes and low-end farming operations where there isn't really deep pockets to be able to deploy financially expensive solutions, you really need to be able to do a few different things. One is, so for example, farmer collectives as a way to share the costs of the technology, to share the risks of adopting technologies, and also to reduce the amount of expertise that's needed by farmers to adopt those technologies. This kind of approach to delivering commercial services or technology services can be much more effective, especially as you look at small plots of land and small farming operations. And so for SMEs to be able to provide these kinds of services to farmer collectives, and also to be able to do it through services, through a service model, as opposed to through a sales model. Because for sales, you really need to be able to pay the upfront cost of adopting the technology, and then also incur all the risks of understanding it, of maintaining it, and if the technology doesn't work well, repairs and many other things become a difficult challenge. A service model in the long run can greatly reduce the barriers to adoption, and it can enable relatively high-tech solutions that would be more difficult to bring to a level of robustness and for widespread adoption and widespread sales. It can really lower the barrier to delivering those kinds of higher tech solutions. So that's one kind of strategy. Another one is that you really do need government incentives to help farmers adopt these kinds of technologies in practice. And this is in some sense a public-private partnership where you have government incentives that enable farmers to be able to adopt technologies and also bear the upfront costs more effectively in adopting these technologies in their farms.
So, sir, would you suggest any policy change for India, or you think the policy is good enough and we just need adoption?
Well, I think Indian policy is very, very extensive, but at the same time, technology is advancing so quickly that you definitely need to be able to evolve in response to the advances in technology, like in a variety of different AI-based technologies. I don't think the current policies are going to be sufficient, but I don't think that it's intractable. I think there is something that through METI, through the Department of Agriculture and others, I think that in fact there can be very effective policy changes that will support adoption of these technologies.
Okay, sir. One question from the other side, that what happens if something goes wrong by the AI? Like, who is responsible? Maybe this is some issue that people have. App to ban gaya, but what if it's right, really right? So is there something you can guarantee that the app is okay? Have you worked on that, sir?
Well, so honestly, I actually think that there are risks with AI. There are potential errors that can happen. There are privacy risks. There are deep fakes. There are all kinds of other AI risks that people talk about. But I think the level of risk varies dramatically from sector to sector. And agriculture is one of those sectors where the risks are much narrower than in many other social domains. And so, for example, an app that might make incorrect predictions, that's not exclusive to AI. This is something that happens routinely even in older technologies as well. And in some ways, more advanced AI-based technologies can be relatively very reliable at a statistical level and have some error rate that has to be moderated and controlled. But I think that it's not likely to be the main showstopper or the main risk factor in limiting the adoption of these kinds of AI-driven applications. I think that there are many other barriers to adoption. In fact, many of the ones that Dr. Mukherjee, that Ms. Mukherjee talked about are much, much more important, I think, than worrying about what might be risks or errors in the applications. For example, I think data access, data ownership policies, investment costs, these are some of the more difficult technical challenges in enabling AI-based apps and technologies to be adopted.
Thank you, sir. That was insightful. I would now like to ask Mr. Meghavi Prashnani. Yeah. Ma'am, you have extensive experience of working on agriculture monitoring, drought assessment, and crop insurance using a combination of microwave and optical satellite data and in situ ground data. Can you tell us more about your work and, of course, related to what just sir said, and perhaps also throw light on the key technological advancements that required scaling to address issues such as water scarcity, soil degradation, and climate change? Thank you, ma'am.
Sure. Thank you for the question. So my work is basically all surrounds the Earth observation. I always I have been working with satellite imagery for past 10 or more years, and for various applications, majorly in for the agriculture applications. So so Earth observation holds a great potential in helping the farmers. But so far what I feel is, the satellites which have been made is mostly it for the global north, but not for the global south, because for the most of the global south, especially India and Africa, we have the smallholder farms, and the satellite which so far have been made have higher, they don't have higher resolution. So that's where we can work more, and especially even for the water, you said water body mapping and then soil degradation and all. There also Earth observation has played various roles. But now we can, with this AI, we can integrate the satellite data with the IoT, with the apps and everything. We can use the integrated system rather than just using the satellite observation, and we can bring on the people from different expertise together on a platform and then work together towards developing the solutions.
Can you give us some, example that you worked hard and it really improved the productivity of agriculture or something like that? Do you have an example of that?
Improving productivity, but okay, so we had kind of used integrated systems using, handheld system, LAI meter, which is leaf area index, and then hyperspectral signature collection using handheld, and we have the satellite and we have the drone. We kind of integrated all these three data, and then that was a monitored field where we used a different type of fertilizers, and then to see what kind of fertilizers are good for the maize crop and whatnot, and these kind of research have been done, to improve the productivity, how much NPK ratio should go and how much not, and then how we can detect it with the satellite data. Yeah.
Thank you very much. And my next question will be to Shekhar sir. Sir, you and your organization are doing remarkable work around establishing AI-driven solutions and ecosystem for the benefit of millions. What skilling strategies you think are needed to be adopted by different stakeholders, private industry, government, to retrain and upskill the current agriculture workforce on AI technology, sir?
I think the first thing that we've tried to do is to make sure that our solutions actually, we take an applied approach, which means that unless people actually can see the solutions work on the ground, it largely is theory. So what we have tried to do in all our AI work, particularly in agriculture as well, is to ensure that we involve individuals across the entire ecosystem. So the first set of pilots that we carried out in one of our interventions, which is to help in the cotton crop by determining the pink bollworm infestation, we literally started with a few hundred farmers in the first kharif, and then you go to 1,000 odd sometime in the next season. It takes some time, and then now we are at a tipping point. We have reached over 120,000 farmers, which is one of the largest ground level implementations in India, which touches farmers. It's extremely important when you work on these solutions to reflect and map on your user community. There are a whole set of principles that you must adopt, which is completely different from the urban user. The rural user, you really don't want to give them drop downs. You don't want to give them complicated things. Your solution should be effective, precise, and answer the question. I would argue that most of us suffer from it even in the urban world, where when you call some advanced services, 16 questions are asked before a service is answered. For the rural farmer who depends on their crop, you simply cannot adopt those strategies. So the first aspect of skilling is to minimize the amount of learning that needs to take place by the end user through effective systems design. Naturally, it will come to most people as to how to use systems. If you look at the adoption of some of the technologies that have taken place across the social spectrum, I don't think many of them did training. The interfaces were such it was easy to learn. That's the design principle. After that, you must systematically understand at a deep domain level how your solution is going to start solving problems for people. Believe me, once you start solving problems for people, everything else goes out of the window. If you give them economic benefits, if you can give them, in that example, reduced pesticide usage, improved yields, one very spectacular side effect that we never thought we would encounter is farmers telling us, in Hindi I'll say, भाई तुम हमारे बारे में सोचते हो technology use करके, यही बड़ी बात है. In other words, you think about us using technology. We are honored. We have conducted literally hundreds of sessions in small groups on skilling, where we go, our teams actually go, sit down in villages, sit in their environments. Our user research team lives with the farmer. A lot of adoption and skilling is about creating connections. It's not about disseminating material. If you cannot create a real connect with the user, nothing will work. If you can, nothing matters. So the approach has to be very, very real. It has to be very honest. It has to be very self-measuring. You will come to know whether the person is understanding what you're saying or not. You will see them operate in the manner in which they're using things. Once there is a set of enthusiasm, it will start getting a lot of additional people using it. Like everything we do, we try and insist to our entire organization that work on the ground, no puns intended. You have to be at that level of engagement with AI in order to demystify it, in order to make it simple to use, in order to make it relevant to use, in order to create the types of interfaces that people find very intuitive and natural. It is my complete conviction that in about 5 to 10 years, people will not use their thumbs on the mobile. They will only use voice-based interfaces. Therefore, in India, one of the things that we are doing is we are enabling the entire voice-based strategies for agriculture. Multiple languages, knowledge elicitation, call center approaches, all of them are multilingual, all of them are voice-enabled. It's going to take some time. It's not going to happen overnight. But the entire skilling will be subservient to the design strategies that you use to solve the problems. If you use a naive design, then you place a lot of burden on teaching. If you use an elegant design, then you reduce the burden on teaching. So we are trying, we're not experts, we're trying to use the latter.
That is very nice, sir. I just want to know whether this work that you have done on design principle, is it available in domain, or you're still working on it?
No, it's fully available on the domain. All our solutions, we work very closely with the Ministry of Agriculture. We have our personnel deeply embedded in the ministry, working closely with them. All our solutions are available. I'll give you one example. We do something called integrated agriculture news monitoring, which takes literally several hundreds of thousands of news articles span India. And the problem statement is find the needle in a haystack. Again, no puns intended. The idea is to look for articles or events of interest that agriculture department may be wanting to look at, whether it's pest infestation, weather-related matters, crop pricing-related matters, pan-India, 10 languages, distill it on a daily basis and make it available to departments. Already in production. This Cotton Ace, the one that we use for cotton, already in production. Several other solutions, all in advanced stages of pilot testing and design. One of the things that we believe in is AI should iterate very quickly. Because what we will get in a lab environment is a very small amount of data, there is no value in working and improving the performance on that. You might as well make a determination it's good enough and use it and take it out to the field. Because when you go to the field, you'll get all the problems. You will get usage characteristics, you will get external factors, you'll get noise. Over a period of time, when you use your solution in such environments, you get a feedback and the solution improves. So our whole idea is deploy fast, iterate many times, work with the communities, understand their problems very well. Some of them are AI, some of them are not, but make sure you're paying attention to it.
Thank you very much, sir. I would now like to go to Dr. Manish Gupta. Sir, your organization is at the forefront of AI revolution. The whole world knows it. what are some case studies and examples of successful models of AI deployment for sustainable agriculture, and how can they be replicated widely? And sir, from a second question is, from a policy perspective, how can the government and private sector collaborate to overcome barriers hindering the adoption of AI technology in the agriculture sector? And do you think it's adequate in India, or some changes are required?
Okay. Yeah, so let me start. So I think we are still relatively early in our journey. I can only point to some of the use cases which are very, very promising. So the work that we are doing is, again, by analyzing the satellite imagery to tackle some of these problems in a scalable manner. And I see our work as really catering to the really bottom, like foundational technologies. So I'll draw an analogy with like mobile payments, right, which has been revolutionized by first this unique identifier through the Aadhaar project, and then this interface, right, UPI interface that was defined. And so what we are doing through the satellite imagery analysis, and Dr. Matthias showed some of that work, is through the usage patterns, we are identifying the field boundaries. So in other words, what we are doing is giving a unique identifier to every farm in the country. So we believe what we have produced is the first such model that is able to identify these different farm boundaries. We are doing this based on usage patterns, right? Based on the crops, what we see on the boundaries of those farms and so on. It may or may not correspond to farm ownership. So one of the, in fact, first use cases that came up was, can you use that to identify, to make more precise land ownership records? This is where we have been partnering with Professor Milind Soni, who's been using the output of our models to, and he has done multiple pilots now in various villages in Maharashtra, and found remarkable levels of accuracy just from, I mean, we have no idea who bought the land, when and how did they pass it on in terms of inheritance, but just based on the usage patterns, we saw remarkable consistency between those usage patterns and actual ownership. The next case that we are really excited about is enabling farmers to get access to loans, reasonably priced insurance. I was horrified to learn, right, that today, I mean, so one of the things that we know is most of the farmers, right, they are unable to get loans from formal banks. So they end up with these loan sharks paying very, very high rates of interest. They are unable to get crop insurance at reasonable prices. And that's where I was saying I was horrified to learn that sometimes the price of, let's say you want to buy cotton insurance for your cotton crop, the insurance may cost you something like close to 30% of the crop value. So who would really afford, right, to buy insurance at such prices? So when there is now crop failure, the kind of problems, for instance, that Vadhvani is working to help avoid, identifying pest outbreaks and so on. But God forbid, right, you do have that pest outbreak, there is crop failure, the farmers are unable, right, to pay that loan, and we have seen incidences of, again, farmers committing suicide and so on. So we believe, again, and it's very heartening to see a lot of startups now beginning to provide solutions where, based on these kinds of patterns, they're able to now, for instance, if you could now identify based on simply the lat long, if now the bank could, a bank which is 100 kilometers away could still, based on satellite imagery, get all of that analysis about the farmer, the ownership, and kind of what crop the farmer is growing, what is the expected yield, the credit worthiness, and now provide loans, or not, or confirm that yes, indeed, the farmer is growing cotton crop for which they're trying to get insurance. So you could make all of these processes much more efficient, and therefore enable all of these use cases. One in the future that we are excited about is, and in fact, I was having a good discussion with Dr. Adve, who told me about some of the professors, right, who are working on how do we financially incentivize regenerative farming practices through carbon credits. Because it so happens that if you adopt those regenerative practices and you do crop rotation, you avoid kind of using some of the chemicals as fertilizers, you do more organic based fertilizers and so on, it increases the carbon holding potential of soil. Today, the only way to really measure that is through these, it's a non-scalable and expensive process that you have to take these soil samples and send them to a lab and again burn that soil and so on, right? And do those expensive lab measurements. If you could now imagine a world where you could now, through satellite imagery analysis and perhaps some drone-based imagery, you could now begin to make this estimation of carbon holding potential of soil more scalable. You could really now start to financially incentivize farmers, right? Instead of preaching to them, oh, this is good for the environment, therefore you should do that. If you can put actual money in their pocket, that'll be a lot more effective. So we are really excited about the potential for those kinds of problems. And of course, that problem today looks very intractable, but we always take inspiration from the work of people like Yossi, that look, nothing is impossible. We have to have a healthy disregard for the impossible. So that's our philosophy, that let's really try to come up with research breakthroughs that will make those problems tractable.
Thank you, sir. Just one question. Like you gave an example of Maharashtra. What do you think would prevent the same adoption in other states of the country? Is it some policy issue or just adoption issue?
No. We are looking at, again, things that can be scaled ideally to all parts of India, and not just all parts of India. We're really excited about scaling them to other parts. So for instance, our colleagues in Google Research Africa, they've built this through satellite imagery, they've built this open buildings data set, identified all of the buildings. So we're looking at mutually, right, how we can take some of the technologies that we have developed in India or technologies that they have developed in Africa and really scale them globally. So, here the main reason is that, I mean, today when you see land ownership, at least I know about the home that my parents owned in New Delhi. I mean, it's a city, but the ownership record only talks about, okay, here's the plot area, and to the north is this, to the west is this, to the east is this, and so on. It doesn't really give you the actual contours of the property. So could you now start providing those precise contours? So that's the early pilots, right, that we are doing in Maharashtra. And my hope is that once we are able to make that work in that state, we can then actually scale it to the rest of India, as well as then parts, of course, regions beyond India as well.
Thank you, sir. And sir, after all this expert, we come back to you, Dr. Yossi. You gave the presentation in the beginning. So after all this, that question that comes to my mind or the group's mind is, how can AI-based solutions be affordable, adoptable, and accessible, especially in the context of Global South, where farmers are not so educated and tech savvy? So that's basically the crux of the entire discussion, sir.
Yeah, thanks for the question. And also I'd like to reflect on a few of the comments on my colleagues here. Earlier I tried to make the case of why AI is transformative, but I want to mention this is not just a silver bullet, you let it do the work, and it's an enabler. And then using this enabler to address difficult problems, but then there are many first principles that we need to address. There were questions about usability, about why people should trust it, about risks. These are all, like with any other technologies, are critical. Let me actually give a few examples on those. So first, let's start with the risk. Even the example I gave with flood forecasting, the reason why we're out in 80 countries is not because we don't have predictions from all countries, is because that's where we have sufficiently high accuracy that we feel that we can actually put it out. Even within these countries, we only show information to places where the accuracy is sufficiently high. So that's part of the process that you need to do in any kind of such an example. Example for trust, we actually, there was a research done by Yale researchers that show that in places that have local volunteers, the likelihood of people taking action on predictions is more than twice. So when you talk about information, technologies, products, and all of that, then that's not enough, because really the real test is what people are doing with the technology, not with technology, with the product, with the information, with alerts. Another example, and there was, I think you mentioned some notion of how to help out with economic incentives before. we did some pilot with an organization called Give Directly in Africa on the following questions. If we know that a flood is coming to a certain place, can we actually, they actually took those predictions and they provided funding to those who are going to be impacted so they can actually take action before flood occurs. Because, you know, to evacuate or to protect your property costs money. Here's another example on the nature of information, which is sometimes surprising. In my first visit to India, it was in Bihar, when we already had kind of a pilot in floods, I came with my team on a field survey to see that on the ground. How does it actually look like? And I still remember the first time that we actually came to a place that we had a contour showing where the flood occurs to see the impact of that flood. So we're very eager to see what's going on. And of course, I expected to see the devastating impact of the flood and all that stuff. And we got to a location and we saw a group of kids playing in a ball on the water, which was not quite the image I expected to see. And then actually when we looked deeper into that, we saw, well, actually what really people need is not where the water is going to be, is actually to know where the water is sufficiently high that they need to actually take action. So actually we went back to the drawing board and we had to do more of the technology to have better prediction of depth, and the product changed to not show where the water is going to be, but actually where the depth is going to be sufficiently significant for people to take action. So information, now again, everything I'm saying here is no different than any other products out there, which is what kind of information people need, what is the interaction, how can they trust it, what's the usability of that, and so forth. So now this goes back to the question of affordability and equitability and how to, again, the impact is not by solving the problem, the impact is by people taking whatever solution you enable them and take action based on that in a way that is helpful for them. Now that's the part where there are many opportunities out there. In fact, there are organizations, for example, one comes to mind is Planet Village. David Yu from that is working on various ways to take and provide information on mobile to farmers in Africa. And again, we need to, in a way, it's like any other product. It's about how to make information, it's actionable in a useful way for people to take action and to find it useful. And I remember, again, this last comment on that perhaps, many years ago, I was sitting on a panel on sustainability and somebody asked me, why is it that people in the US don't care enough about climate change and sustainability? And my hypothesis was that it's not that they don't care enough, it's just that the actions that we expect them to take are actually, in most cases, not practical. And the analogy I gave is the following. Suppose you hold a can of soda, and you have recycling being next to you and it's just a waste. Most people would actually use the recycling bin, right? Because they'd like to do something good about, for the environment. Now, let's suppose that the recycling bin is now, a little farther away. Well, suddenly a few of them are not going to go that far. They're going to say, well, I'd like to, but I'm too busy. Take it farther away and already very fewer people would actually use that and do the right thing because they are busy, they have other stuff, they just didn't. So the analogy here is how can we use products and technology to make it easy for people to take the right action that is going to be helpful for them and for the environment, for the planet. And that's actually, in a way, no different challenge than any technology and any product out there, which is how to make it acceptable, useful. Now, on the positives, on the opportunity side, everybody has a mobile now. And the power of providing information there and do it in a way that is useful, I think is there. And again, that's where innovation plays a role. That's why, as I mentioned, startups play a really important role because at the end of the day, for every problem that you'd like to think about, you may need special attention to think about it. There's no silver bullet that is just going to solve everything and know how to do that. Perhaps, who knows, in 5-10 years, AI can also find the right user interface to provide the right information to the right people. But I think there are a host of many problems, and each problem is an opportunity. So we need to find a way to actually make it useful. And the real test is the action that people can take that is going to solve the real problem for them.
Thank you, sir. And We have about 20 minutes. Maybe we can take some questions from the audience. Any questions from the audience? Yeah. Please give the mic to him.
Hello, sir. I'm Vineet from Digital Green, and really could relate to all the points, especially the point that was about the simplicity and usability, so that the farmers can actually use it. Now, one of the things that we have been building is, so we are in the we are in the business of actually last mile information dissemination as a not-for-profit entity. And I think the use of AI, we have been able to build the interface on, so that we can actually disseminate the information in a very simple manner. And we are seeing very great results. But I think one of the points was also that we need what we are seeing on the ground, that we need to have people as well. We are talking about satellite, drones, and so on. But there's a lot of crowdsourcing of the information that can be done. One of the very common example is related to one project that we did in Bihar, where we wanted to estimate greenhouse gas emissions. And for that, what we found out was that the information that we need to collect is very cumbersome. So I wanted to know the thoughts on how to incentivize the crowdsourcing of the information and how can it be made more simplistic. Thank you.
Sir, would you like to ask a question?
It's a very good question because it's fundamental to adoption. So one of the things that we have started doing is, just under the name of AgriCollect, create something called a farmer diary. The goal of a farmer diary, and we have started rolling it out slowly, is to complement and start soliciting ground truth. So in as much as you have information, we have both ends of the spectrum. I do one project where I do the entire land mapping of India and determine which crop is growing where. But I would also like to do the ground level truthing of that place to understand from the farmer what they're doing. So it's a very important aspect that you've brought. So the tone needs to be greater conversation with the farmer. When I say conversation, I've purposely used an unstructured term. And the reason is because I don't want to assume that I know what they want to say. I just want to listen to them. So how do you listen to a farmer? You listen to a farmer by soliciting data on the ground, and you employ certain systems. And over a period of time, if you can get something back to them from it, small pieces of advantage in their life, suddenly things become meaningful. This is one way. Second, there is something called Krishi Call Center. It gets 25 to 30,000 calls a day. We're working on that. We're taking all those calls, converting the voice to text, understanding the types of questions that the farmer will ask. There are farm agents who respond back to them, participate in that, structure the database, make sure the knowledge base gets created, and then respond back to the farmers in a far more intelligent manner. Second form of engaging with them. Third, we are working under the PM Kisan, which has been launched by the Honorable Prime Minister, for grievance redressal. The goal is in 2024, we would have an AI system that will assist in grievance redressal. That is a third way. My pet actually theme is grievance redressal is a curative process that works on the efficiency of response. The real problem is prevention. So if you can graduate from curation to prevention, which means today, rather than answering a question very fast to a farmer in the stated language, can you tell the farmer that they're going to get this problem? Can you advise the farmer contextually as to what is useful for him or her? These are different ways. So the more you engage, like you tap yourself into the conversations at different levels, the greater the richness of information that you get. Whether it is text, voice, information, structured, what they do. And these are very early stages. We're already there in several of this. The real advantage will come when you can create patterns out of this. where you can create archetypes or patterns that allows you to summarize and have a much better ability to respond. Finally, it is my considered observation that this is a market of one. You have to answer that one farmer exactly what they want to know. If you formulate the problem like that, you take the burden on yourself as a technologist, rather than blaming what they're, "Arey, kuch samajh mein nahi aata, I don't understand." All that is gone. Your job is to respond to that one farmer. So that's how we are addressing it.
Thank you. That was very, very interesting answer, sir. And can I ask Dr. Manish, do you have any insight on this, on the data question that he has?
Yeah, so I agree, because ultimately the best incentive is when you're delivering real value to the farmer. So if, and sometimes, I mean, if in that process, what we have shown is that we are showing them, look, this is what we believe exists, and we give them simple ways to correct whatever is the output of the model. Often, right, they are willing to do that. So I would really agree with Shekhar that A, deliver them value, and B, the interface has to be very, very simple. And there are, again, other contexts, like we are also trying to, again, democratize access to information to every person in their local language and so on. And in that process, again, we are collecting a lot of like speech data from every district of India, right? The project that Partha Talukdar is leading together with ISC. Again, I mean, the idea is to use, again, this whole richness of languages and so on, and ultimately build those capabilities in the models that you would be able to respond to them in their own local language in the preferred kind of medium, right, which would be ideally voice-based.
Thank you, sir. Any other expert who has a comment to make? You have a comment to make? Since you're collecting a lot of data? No? Okay. So
I've collected the data.
Yeah.
I've collected the data, but that is like ground truth. So just to, train my models and all, but I have not directly, collected the other data from the farmer, which is, like it's for the crop mapping and yield mapping and all,
Yes.
One point which I forgot, I think this is arguably the most important. Contextuality is the most important thing in AI. So AI, let's assume there's a farmer on a field. If we understand the context of the individual at the time, then the knowledge elicitation and dissemination will be very precise. Presumably he's not going to sing a Bollywood song, nor play cricket. He's or she has gone there for a specific reason. And if you can ask the question of relevance and importance, context, with respect to everything you have around it, environment, weather, crop, time of season, Kharif, Rabi, why are people going there, morning, evening, these are your data points. The more contextual you become, the more relevant you become. The more relevant you become, chances are they will adopt you. Once they adopt you, it means nothing. It means they are starting to willing to speak to you. Then you have to pay a lot of attention to the responses they give, introspect on it, understand all your failings, which will be several when you do an AI implementation, and then improve the performance, and then build trust. So it's a standard pattern. We are working on 30 solutions across all spaces. It's a very repeatable pattern. This is the standard norm of doing AI projects.
Yes, ma'am.
So I can just give I can just give a few examples here. So I was trying to unpack the question a little bit more. But when you talk about specificity, I can't underscore how much, and I really like what some of the panelists said is it's that farmer's problem that you're trying to solve for. So I really love the point that it's n is equal to 1. Because we might be dealing with n is equal to 10,000 when we're looking at AI or big data, but it's really that one person's problem you're trying to solve. So the two quick examples that come to mind, one is that Dr. Yossi was talking about Plant Village. So we are working with Plant Village in Kenya, where we are working with they have an app called the Nuru app. And what it essentially does is it helps farmers diagnose and treat plant diseases, plant pests and diseases. So these farmers are essentially taking these photographs of their crop and they're uploading them. And then there is an algorithm which is actually, advanced enough to look at every single photograph and then give them some information based on that for each individual photograph. So you have to imagine, even at the back end, what sort of amounts of data must be going in to be able to even sort of process that at a granular level. Another quick example is in Bangladesh. We are working with these farmers where they're uploading pictures of their leaf color of leaves, and then in that leaf color, at the back end, there's again this whole AI thing. You can imagine how you can train AI to be able to just identify different colors of leaves and then give you information. But that information also then there's a little bit of in the future saying how can you prevent such things. So you have to be able to feed in that information as well. There is some amount of, I think, hand-holding as well. So you can't just rely on the app. So there is a human interface where there is some training on crop yield patterns, in the climate conditions, all of that is also fed in. So as specific as you can be, but then again, the data that we're collecting is thousands of farmers. But then again, this is one farmer who's benefiting from this.
Like say something, sir?
Yeah, just want to add that at the end of the day, a person is a person, a user is a user. So in a way, even though these are very heavy problems, they are about the economics opportunities, their livelihood, etc. At the end of the day, when you talk about how to get to use technology, products, information, in a way, it's not dissimilar from any other product out there. Many years ago, there was this notion, people called it the consumerization of the enterprise. That's where people were talking about how some habits that we have in our, in the use of products as consumers are something that encroaches about our day-to-day at work. Now, today, I don't think anybody would say that because it already happened, right? I mean, all the old software that used to be in the enterprise mostly is now very similar to what we're using to have a chat between ourselves and to other consume information out there. So the basic principles are there, which is how to be helpful, how to find a simple way for people to consume information, how to learn what are the values that we're solving, how to build a trust with the user, the right habits, and of course the incentives are different, even though some would argue that the incentives of somebody to use an app that can help their, their farming may not be stronger than a teenager that needs to communicate with their friends. So in a way, it's not dissimilar. Perhaps these different users, of course. So going back to basic principles of UX and product and all of that. Now, this is only on the adoption side, on the usability side, but you cannot distinguish that from the depth of the technology, because when you talk about trusting information, and again, of course, I've been working for over a decade on search at Google, and what you learn is that the first thing is that the quality of the content makes a difference. So you want to trust that it gives you the right value. The simplicity then gives value. We used to say that it's still true, I guess, that there's one feature that we always learn is extremely important in search, which is speed, how fast you get the results, so usability. And if you think about it, in search, people come to Google to look for information, but the speed matters, so this user experience also matters. So I think that's true for other things as well. It should be simple, as with other products, and it should be valuable. And that goes to the depth of the quality of the information that is provided, how it's presented, how much can you trust it. And again, if I reflect back on one thing that is extremely important, for example, in flood forecasting, is to have a really high bar of accuracy and confidence on what we show in predictions, because there are so many times that you can actually alert on something which turns out to be incorrect, then you lose user trust and it's not valuable any longer. And by the way, this is something that I think in various places in the world, people learned it the hard way. They had all these apps in the mobile that alerts people on various events. I think it was in the US, there was the Amber Alert that was very broad. And now the intention was good because it was to actually let more people know that they should actually help out identifying a missing child. However, what turned out is that because it was ringing so often to so many people just muted it, and it became totally useless, unfortunately. So like any technology, you need to provide value. And so it all goes hand in hand. When you have the right depth of technology that gives the right predictions and the right accuracy of data, and then you put it in just the right way to the user, and the person receives value, then that's where it becomes usable. And I think, again, not dissimilar from any other product out there, except that here it's something that people obviously need, so the motivation is hard. So presumably people will make this extra effort to use whenever it's there and it's useful, but still I would encourage to think about it like any other product. Make it simple, useful, and take it from there.
Thank you, sir.
I have one point to add.
Yeah, please.
So it's not about incentivizing the farmers, but since we need so much of data for our deep learning models and AI, the more the data, the better for us. So we have a helmet project. It's in Africa, where people put GoPro in their head, in their helmet, and then they go around the roads, and then they click the pictures in a certain interval, and this kind of feeds them our models. And second, what we can do to incentivize the farmers in India is maybe conduct some gaming app or something, so that every village they get some the more pictures you collect from the farms, the more the one first prize winners gets 5,000 rupees or 2,000 rupees or something like that. Some farmers or maybe school kids can go and collect the data from the farms, just clicking pictures only for the crop type mapping or something. And this way, no, I'm not talking about the yield map and all, because for the yield data, there could be the privacy issues or something, but just for the crop type mapping, just to build a better crop type mapping, we can have some gamifying apps and all. Yeah.
That's a good suggestion. So any other, you had a question?
I just wanted to add one small point.
Mike.
So in terms of incentivizing and all, when you're talking about, so one other way which could be explored is, in agriculture, people have had a lot of success with cooperatives everywhere. Now, in case of data also, we could try to have data cooperatives where people are, let's say, whoever is contributing their data, farmers or in any other form of crowdsourcing when we are going about it, that rather than companies owning the data, they just become custodians. They have a fiduciary duty to them, and they have to finally share some proceeds. So yeah, like Google is here. Like Google has become the biggest company, or one of the biggest companies in the world, by using other. So we all get free services, but a lot of people now resent that. Okay, maybe we could also get some shares of those proceeds. So it's not like it's just like, how do you bring in that element? And I think cooperative structure for data ownership and data governance could be a really interesting way to explore everywhere.
Thank you.
Can I say something
Yes,
about that? So I think that's a really good idea in principle, if we can get farmers to take that approach of building cooperatives and trying to take advantage of their own data. And in fact, in the state where we work in Illinois, very recently a group of farmers did exactly that. There's about 100 or 200 farmers that had come together because they all have valuable data. It turned out that one of those farmers, a couple of the farmers actually had previously founded a company that was based on data and commercialized it. And so they had the experience with what was required to monetize that data. I think, unfortunately, most farmers don't have that expertise or experience and don't know people who do. And so trying to, so effectively, farmers by themselves will not have the expertise or the understanding of how to go about taking advantage of the data that they do have. But either as a government policy or as an NGO or as a small or medium enterprise, I think people could actually create structures or create incentives that encourage farmers to go out and form these collectives and offer the data sets. So by offering products or offering to build products and help the farmers monetize them. So I think in some sense, even that process of creating collectives for data is something that can be externally incentivized, and you can create ways to encourage farmers to do that, because then they will really be able to take advantage of their own data, the data coming off their farms, instead of just giving it to some multinational corporation or something else who today is basically the only ones that actually are able to make economic advantage out of that data, out of those data sets.
So I'll just add one more point here. So, so we all love data because data can tell us many things, and we work with lots of big data sets. We collect our own data, and we also work with a lot of government's administrative data. I think one big, now that we are embarking on this AI journey, I think one big thing to watch out for is actually how do we make these data sets standard? So more standardizing a lot of these data sets. And I think for all of the data that One AI is collecting, Google is collecting, I think there's a lot of value add to being able to make these standardized, accessible, but also being able to, how do you sort of bring together many different data sets together. So it's a I call it a cyclical economy, right? Not cyclical, circular economy. So everything is related to each other. So it's like a house of cards. So you need to be able to connect all of the dots between between different houses before they all fall together. So that's and I think MeitY is doing a good job now of thinking through about the data privacy laws. In India, I think there's a lot to be said for who's collecting the data, how to collect the data, data sharing, all of that privacy laws. We have a very long way to go to be able to, just connect all of these things together.
One of the things I would advocate for is to create more open data sets. In fact, in India, already we spend a lot of money on collecting. So the government of India had this program of soil health data cards, where there's so much of testing that's been done. The government of Karnataka, I was told, spend something like, I don't know if I have the number right, something like 8,000 crore rupees annually to do this survey where they collect data on what is being grown in every farm. A lot of these data efforts, I mean, these are very well-intentioned, but the quality of the data is not as good, right, as you would like it to be. So in my mind, again, open data could be a way because, again, nothing's like, people say sunlight is the best disinfectant. When there is data being shared openly, automatically there is that pressure to make that data higher quality. And as the data gets shared, right, you begin to see, again, in some sense, errors and so on being pointed out. So I agree long term with where you're going, that yes, it would be good to figure out ways in which some of the value could be shared back with the farmers. But the first step, at least I would advocate, is for us to jointly start creating more of open data sets so that at least collectively, the technology companies, agri-tech companies, and people who are building those solutions can at least start to use all of that data to start delivering value to farmers.
Thank you, sir. And the final comments from Dr. Yossi as the time is up. Sir, your final comment on this.
Yeah, so first, thanks for the question. I think it's a really important point. I'm a very strong advocate, and we are very strong advocates for open data. Even on floods, for example, we put a data set out there for all the public data which is out there and encouraging others to put. It's a project called Caravan that we published in Nature Science. Similarly, by the way, the models we're trying to put in GitHub so that others could also use. And this is an approach I'd like to see happen in other areas as well, certainly in everything that has to do with agriculture. Eventually, that's how we're going to get the insights and everybody's going to benefit. Now, you touched on some opportunities that there may be some economic incentives to also do some other, which is totally fine, by the way. I think that in the future, there are going to be some ways also to both contribute the data as well as keep it yours. So in a way to eat the cake and keep it. By using further the learning and differential privacy and all sorts of other technologies, which is also fine. But that's actually where the opportunity lies, is in how to actually get the insights. And then indeed data is the fuel of building those machine learning models that eventually enable us to do some of the AI magic that we have. So +1 to this open data approach that Manish and others were touching on.
Thank you very much, and it has been a very insightful session. And as you have the mementos ready? Mementos ready?
Yes, sir.
Yeah. So as a token of appreciation from the ministry, we'd like to present a memento to all the experts. Thank you, sir. And thank you everyone for coming here.